Welcome to Investigation 3.1, Comparing Security Services. In this investigation, we're going to be looking primarily at linear equalities. So we're no longer just looking at linear equations, y equals mx plus b, in that standard form ax plus by equals c, but we're actually looking at y is less than mx plus b, or we're going to be getting into that situation. So we're going to be playing around with this whole concept of things being not equal to each other. So let's get some of our terminology down. Inequality, if we have a less than sign, we're looking at something less than, and we can read them from left to right. If I look at this left-hand side, it's smaller than the right-hand side. So if I read it from left to right, I'd see that the front sign is less, so it's less than. Then we have greater than, and we have that same rule that's applying. The greater than is reading from left to right, so we're seeing that it's greater on this side than it is on the right-hand side. So it's a greater than sign. We then have also less than or equal to signs and greater than or equal to signs. And that's the same sign as the previous ones, but it has the extra line underneath to show equality as well. So now let's play around with this investigation. This is part A of this investigation, kind of sets you up for at least the first couple of parts, A and B. So we have Superlocks and Failsafe. They're two security companies. Superlocks cost $3,975 for installing the security system, and then $6 per day for monitoring. Failsafe is $9.95 for installation, but they cost $17.95 a day for monitoring. So we can see that Superlocks initially costs a lot to install the security system, but it doesn't cost very much to keep it up, whereas Failsafe costs a small amount, but then costs a lot more to keep it up. So we're going to use these two equations, and we are going to answer this first question. For what number of days will the costs of the two companies be the same? So we're going to be doing exactly what we have been. We're going to use the sort of substitution method to solve this. So first thing that we need to do to be able to do this is we need to actually figure out the number of days. So we need to figure out a couple of equations. So we're going to move this over and create a couple of those equations. For the Superlocks company, we can say we're getting $6 per day plus $3,975. And then for Failsafe, that costs us $17.95 per day plus $9.95 for installation. So using this information, we're going to be looking at when the costs are the same. So we're going to actually set these two equations equal to each other. So let's do just that and solve for this. We end up getting 6D plus 3,975 is equal to 1795 D plus 995. And we're just going to solve. So I'm going to go through that process. I'm going to subtract 6D on each side, so I get my D's on one side. So I get 3,975 is equal to 1195 D plus 995. I'm then going to subtract 995 from both sides, and I end up getting 2,980 is equal to 1195D, and then I'm going to divide by 1195 on both sides. So my final answer is 249.4 days for D. We can also figure out the cost by just putting this amount into one of those two equations, but let's look at this graph really quick. We can see at about 250 or 249 days, oops, dropped my stuff. At about 249 days, we can see that these two lines cross in the same place. And then we can also see that it's at about $5,500 that occurs. So that's kind of nice. We can see that information. For what number of days will Superlocks cost less than Failsafe? So in this situation, if we look at our initial graphs, Superlocks started out much higher and ended up growing at a very fast rate. However, we're not necessarily looking at that information. We are looking for when superlux is cheaper. So, or a very slow rate, I should say. It ended up growing at a slow rate. So we are looking at this information. When was superlux cheaper than failsafe? And that's the point in time when these graphs sort of switch spots, and that happens at that intersection point that we were just discussing. So at that intersection point, we can see that superlux is cheaper. So C sub S, superlux, is less than failsafe at 250 days plus. So at 250 days, if I put that information in, superlux would be cheaper. Then for what numbers of days will failsafe cost less than superlux? So when is failsafe less than superlux? And that happens at this point in time, everything less than here, when the blue line is less than. So that's between 0 and 249 days. Or 248 days. Between those days, failsafe is cheaper. So you're going to continue and you're going to do part B, and you're going to be eventually creating equations, or creating lines for those equations, and you're going to have to answer the same sort of scenarios. You're going to have to say, when is one of these equations cheaper or less than the other equation? And so you're going to need to graph in the same sort of way and think about these times when one's less than the other and sort of identify those locations. So now we have to look at the concept of inequalities. And this is something that you've been working with a little bit in 6th and 7th grade, and how to graph them on a number line. So eventually you're going to get to the point where you're going to graph them on a coordinate plane as well. However, in this case, we're going to be looking at our inequalities on a number line. How do we graph x is less than 3? X is less than 3. Well, we'd look at a number line, we'd create a number line, and find -3, and we'd put a circle around it and say everything less than that is x. So -4, -5, -100. All of that works for this inequality. Then what if we had x is greater than 6? Well, we're going to do the same thing. We're going to find 6 on our number line. There we go. And it's everything that's greater than that. Sweet. What if we end up having x is less than or equal to 1? Or greater than or equal to 1. Oh goodness, I said that horribly. Greater than, because I need to read it from left to right. What if x is greater than or equal to 1? Well, in this case, we're going to be looking for that same thing. We're going to be looking for the 1. And instead of just circling it, I'm going to fill in this circle. Because when I fill in the circle, I'm saying that it's also equal to that. It can be 1. And it's everything above that. So 2, 3, 4 would work, but also the number 1 is greater than or equal to 1. And so we're going to be playing around with this idea and graphing things on a number line. But we're going to up the ante. So you've done this sort of stuff in 7th grade. Now you need to be able to do this. We have an actual inequality equation per se. So we need to take this information, 2x minus 6 is less than -4, and we need to be able to graph that. Looking at this, I don't see a way that I can graph it. I don't know what x is less than or equal to graph it. But what I can do is I can solve this inequality. And one thing about solving inequalities is you have to pay attention to this inequality sign and treat it almost as if it were an equal sign. But know that if you do certain things, which we'll discover in the next couple of investigations, if you do certain things, that inequality sign might change a little bit. But I'm still going to do this whole thing of creating a vertical line so I can see what I do on one side will end up reflecting on the other side. So I have 2x minus 6 is less than -4. I'm going to add 6 to both sides. Because if I add 6, I'm getting my x by itself. I'm working from the inside or outside in. So I get 2x is left over, and that is less than -4 plus 6 gets me a +2. And then after that, I'm going to divide by 2 on both sides, and I'll get x is less than 2 divided by 2, which is 1. So x is less than 1 for this scenario. Only x's that are less than 1. So 0, -1, -2, -3, -100. Like always, I always say that. Those work. Those are values that work. So essentially now we can go up to this point on this number line and say 2x minus 6 is less than 4 when x is less than 1. And so we can then draw our circle, our empty circle, and the arrow down to the left for the less than part. Kind of cool, huh? Well, this is what this investigation is all about. You're going to be doing this for Part C and Part D. Part A and B, you're going to be looking at these sort of graphing scenarios. Try your hand at this information, and if you have any questions, as always, please do not hesitate to ask. Please, please, please. And I hope this helps. Have a good day. Bye.